Let me give an economic example of this. Suppose we have this demand function. Q equals 100 minus P minus 1/2 P squared. And now we're going to make the domain, since P is price, we're going to say the price has to be greater than or equal to 0. We're going to restrict the domain to just be values of price greater than or equal to 0. Okay. Now, how, in this case, obviously Q is a function of price, because if you plug in price, you get a unique value of Q there. So Q is a function of price, but is price a function of Q? Can you express price as a function of Q? Does the inverse function exist? Well, what would be the steps we go through, David? What would be the steps we go through to? Okay, find the derivative of Q with respect to P. And what is dq dp, David? Okay, the derivative of this part is minus 1 minus P. Right. Now, if P is restricted to be greater than or equal to 0, what could you say about dq dp? What could you say about its sign? It's always negative. Because even if price were 0, dq dp would be minus 1. But if price were positive, then you'd have 2 negative terms you'd be adding up. So this is always less than 0. So what kind of function is this function right here, David? F of P is what kind of function? Yes, exactly. Is a monotonic decreasing function. So, does the inverse function exist? Yes, because anytime you have a monotonic function, that means the inverse function does exist. And suppose you wanted dp dq. What would it equal? Well, by the inverse function rule, I'm just switching notation now. Instead of y, we have q. Instead of x, we have p. So dp dq is going to be what by the inverse function rule? Okay, yes, it's going to be, Ryan, 1 over dq dp. And Ryan, dq dp here we figured out is this. Okay, so that's dp dq. Okay, actually this is kind of slick because you wouldn't be able to solve for p as a function of q directly. Nevertheless, by this inverse function rule, you can get dp dq. Okay, so that's the inverse function rule. Okay. Does that make sense to you? Okay. First, what you need to establish is whether or not the function's monotonic. If the function's monotonic, then you know the inverse function exists. And you can use this inverse function rule to find the derivative.